I'm going to go over detecting cable deterioration before the fault, which is essentially a bunch of diagnostic methods. And the topics I'm hoping to cover are even the basics, like the parts of the cable, wire testing your cables, different cable types, and of course various testing methods, like your withstand testing, what very low frequency is, which is a big question, VLF withstand testing, hand delta diagnostics, and partial discharge diagnostic. So this is hoping what I'm covering. Hopefully I'll be able to cover all this stuff right here very clearly. All right. To kind of establish a baseline and go over the generic stuff for cables, I really want to go over the parts of the cables and to get a good familiarity. Alrighty. So starting with the cable, we have the conductor on top, of course, and typically it's made out of copper or aluminum. It's solid or stranded. Next, we have our conductor shield, and then we have the insulation. And the insulation, there's various types of insulation in various colors, and we'll go over that as well. And then we have the insulation shield, and the insulation shield is also commonly known as a semicon. And then we have our metallic shield, and there's different names for the metallic shield because there's different types of shields. Like we have concentric neutral wire, we have tape shields out there, there's flat wires, there's strain wires. They're all types of metallic shields. And then we have our jacket, and the jacket is our moisture barrier for our cable. Typically it has stuff like the manufacturer on there, or the cable rating, or the insulation type, stuff like that on the jacket. So those are your basics of your cable. And why are we testing cables? Well, throughout the cable's life, they're actually subjected to various types of stresses. Like you have thermal stresses from short circuit currents, or electrical stresses from transients. You have mechanical stresses from the bending radius being too tight. And of course you have environmental issues like being in a high moisture area, being in a high area or something. But all these stresses will age and degrade the cable over time, which of course leads up to cable failures. And one of the leading aging conditions of medium voltage cables is something called a water tree. And a water tree is moisture that's stuck inside the cable, and it forms a tree-like structure, or like a bush-like structure. And all you need to have a water tree are three ingredients. You need AC voltage, you need moisture, and time. And if you have these three ingredients, you can have potentially water trees inside your cable. And you can also have not just like one water tree, you could actually have them all over your cable. They could be coming from the conductor, they could be coming from the semicon, but only one of these guys needs to convert to something called an electrical tree, which is a carbonized path, to create a cable failure. All right. And because you have water trees all over your cable, this is considered something like a global issue. And you also have more localized issues, of course, like you have a bad joint, you can have a bad termination, you can have a localized weak spot, like a bad, like a localized water tree, or like an insulation dig-in, something like that. Right. And so when it comes to testing, there are three different occasions that people test. First one is for commissioning, and so you're checking your cable system before you actually put it in service and making sure everything's okay. Someone could have done a repair on the cable, and so you're checking to see if the repair is going to hold. And then there's also, of course, there's maintenance testing, which checks the condition of the cable system. All right. So what tests are there? What can you do to do testing? Like which test does what? There's various types of tests. Like I was saying earlier, there's the withstand test. And there's three different versions. You have a DC withstand test. You have an AC power frequency withstand test. There's an AC VLF withstand test. And of course, there's hand delta diagnostics and partial discharge diagnostics. And each test has a different purpose. And just as a little FYI, there is something called a sheath test, which tests the jacket. And there's something called conductor resistance that you could use to check the conductor continuity as well. But I'm mainly going to go over the withstand test, hand delta diagnostics, and partial discharge.